Okay, this video is about giant ones and restricted values. So when we are working with a rational expression, what we are doing to simplify the expression is to get rid of the extra fluff, the things that we don't really need. So remember, the algorithm for multiplying fractions is that you multiply numerator times numerator, denominator times denominator. That can go in both directions. So just like we can multiply numerator times numerator and get this, denominator times denominator and get this, we could break it apart into two fractions. So I'm going to break this fraction up into two fractions. The first fraction, I'm also going to rearrange the factors. Since we're using multiplication, factors are being multiplied. You can always rearrange them. So I switched the order of the two factors in the denominator. I just swapped them because it's this factor times this factor. These parentheses mean times. So I can always just switch the order. The other thing I did is I broke it up into two fractions. And in practice, when you're actually doing this, you probably skip this step, but I want you to I'm going to really drive it home right now. So I broke it up into two fractions because it's the algorithm. Numerator times numerator would give you this numerator, denominator times denominator would give you this denominator. By breaking it up this way, you can see x minus 3 over x minus 3 is actually equal to 1. And I'm going to make this giant 1 here so it doesn't disappear, but we can see that we really just have 1. Let's talk about why this is 1. Okay, so x minus 3 over x minus 3. This is an expression, and we have a variable x. That means x can be any number in the whole world. So you could think of any number you want, and you could plug it in for x. So let's pick a number. It doesn't have to be. It could be anything we want. Let's say we pick 10. We can see that 10 minus 3 over 10 minus 3 is 7 over 7, which equals 1. That would have worked for 52, 79. That would have worked for the square root of 3. That could literally, for any number you can think of for x, if you plug it in to both places, you're going to get the same thing in the numerator and the same thing in the denominator, so it's going to equal 1. So it equals 1 all the time. Except, were you waiting for that but? Except, there is one small exception to it equaling 1. If x were to be 3, you would have 3 minus 3 over 3 minus 3, which is 0 over 0. 0 over 0 is not 1. 0 over 0 is actually undefined because we don't know. We have nothing. We're dividing it by nothing. That should leave us with nothing. But when we have the same thing in the numerator and the denominator, it's funky. So it's undefined. We can't agree on whether it should be 0 or 1. So we agree that it's neither, and it's undefined. So this could not be simplified if x had been 3. If x had been 3, the whole problem would have to be thrown out, because then you would get 0 over 0. So when you make this 1 here, you say this is 1 as long as x isn't 3. Everything's good to go unless x is 3. So that's your first restricted value. Now what are you left with? You have your answer here of x plus 5 over 2x minus 1. And this is your final solution. So we are working with expressions. So we're not finding out what x is. X could be anything, except 3, of course. We're just simplifying. We're making the problem have less factors in it, so it's a little bit simpler to work with. Eventually, later on this year, we'll be graphing these, and you're going to want the problem to be as simple as possible. So since you're just simplifying an expression, your answer will still be an expression. But there is one more restricted value. If this denominator were to be 0, then you would have something divided by 0, and that would not be okay. So what would make the denominator here equal to 0? So what we do is we think to ourselves, what would make 2x minus 1 equal to 0? How would that work? And all we need to do here is just solve this equation. So 2x equals 1, divided by 2, x is 1/2. So if x were 1/2, the denominator would be 0. And we can't have a denominator equal to 0. If you haven't watched that video yet, there's a whole other video about why we can't divide by 0. So this expression wouldn't really work out for us if x were to equal 1/2, because then our denominator would be 0. So x can also not equal 1/2. So we have two restricted values. The first one comes from this not being a giant 1. The second one comes from the denominator equaling 0. Now, sometimes people think that the numerator can't equal 0. That's not true. The numerator could very much be 0. If this was -5, the numerator would be 0. This would be some value. It doesn't even matter what it is. 0 divided by anything is 0. So you can have a numerator that is 0. So -5 is not a restricted value. Your only restricted values are 3 and 1/2.